for loop. So we'll look at this demo of for loop with an example. So you can see that I'm just directly initializing int I is equal to 0, and I'm checking if I value is less than 100, then get inside this block. So let me explain you how the procedure goes. First, it will initialize the values whatever you have declared in the initialization part, and then checks for the condition. If the condition is true, then execute all the statements, and then go ahead to execute the increment or decrement part, and then again check for the condition. If it is true, execute the statements again. So until the condition becomes false, the for loop is going to get executed. So here I have declared I is less than 100. So until I reaches the value of 100, this loop gets executed. So I'm just going to run this, and we can see that from 0 to 99 we will get all the numbers printed here. This is a simple example of a for loop where you can have the initialization part and incrementing part in one statement. So next, coming to the break statement, we have already seen a break in the switch which is used to limit the execution for one particular case alone, whereas in this break what we are going to use this is that we'll be using these break and continue in the loops to take the control outside the loop. When break is used, whatever loop you are there in, the execution is in, this will be going on, the current loop will be terminated and will come out of the loop. So let us see this with an example actually. So if you see this break demo, I have a for loop where I'm iterating it to look for if I is less than 100. That means it is going to execute for 100 times, 0 to 99, and I'm checking if the value of I is a multiple of 13, and if the value of I is equal to 65, then I'm breaking it here. So I'm just trying to print the multiples of 13, except if I'm getting 65, I'm telling the loop to break here. So all the values that are all the multiples of 13 that are below 65 will get printed. But when 65 is encountered, the break statement will get executed and the control will come out of the loop. So I'm just going to demonstrate this. You can see that the control came up to 52, and when 65 has come, this is breaking up. If I comment this, it will happily go with the full length execution of the for loop. So you can see that it is printing up to 91 and without any problem, and then quitting the loop. So this is the advantage of the break, that you can take the control with some exceptional conditions where you want to break out of the loop and come out. And with the continue, without breaking, you want the loop to continue with the next iteration rather than going ahead with the current iteration. Say for example, now I just want to skip the multiples of 13. I can say to go ahead here. I can say just don't print 65. I'm just saying continue with the next level. So instead of break, I just gave continue here. So 65 will not be printed. Instead it will go ahead with the execution of the rest of the iteration. So you can see that 65 is just skipped. So when a continue is encountered, the rest of the statements inside the loop will never get executed, and the iteration control will go here, and then the loop will continue normally. So that's the advantage of the continue. Without breaking the loop, it keeps going on. And then the last thing is in this is the return statement. When you use the return statement, the control will be given back to the calling method. That means I'll show you this with a demo. I have a multiples method in which I'm just printing the multiples of a number. Say I'm sending 5, I'm just printing multiples of 5 into 1, 5 into 2, something like that. But when I value is 9, I'm just telling the control should go back to the method from which this method has been actually called. So from the main method I'm calling the multiples, and I'm telling here to print the multiples of 5. So whenever the I value of is going to become 9, the control comes here and this statement will get printed here. You can see that. So whenever I'm getting 5 8s of 40 and 5 9s is not coming, so I'm getting the control back here. So even if I whenever the return is coming, return statement is coming up, I'm not no other statements inside this method after that will get executed, even if it is outside the loop or whatever. So when a return statement is getting executed, the total control goes back to the method which has actually invoked this. Then coming to the labeled break and labeled continue, these statements are actually used to break or continue from the nested loops. So we'll see this with the demo. Here I have a labeled continue here. You can see that I have two for loops. The first for loop is having I is equal to 2, where I is less than 10, and the second for loop I have initialized j is equal to 1, and I'm just printing I into j here. But I just don't want to print the value of value when I is equal to 7. That means say this is a multiples table, say all the multiples will get printed except the multiples of 7. So I'm just telling that continue with the next set of iteration of with value of I getting incremented to next set, instead of continuing with I is equal to 7. So it will print all the multiples except 7. So you can see that 6 is getting printed and 8 is getting printed, but 7 is ignored. But in the same fashion, if you give the break statement, so I'm telling break from the first for loop. Here you can see I have mentioned the label. I'm very specifically telling break from the first instead of breaking from this second loop. So this is the meaning of the labeled break and continue, where you are specifically telling to quit from a particular for loop, which this break or continue should be part of that loop. Then only the control will be possible. So if I execute this, you can see that only up to 6 it is getting printed, and rest of the numbers are getting ignored. So that's the importance of the labeled break and continue. So that's all about the Java control statements. Thank you, and visit java9s.com and leave your comments as a feedback. Thank you.